Hello and welcome to lesson 3.4. In this lesson, we're going to be trying to solve radical equations. We've been working with radical expressions and radical equations for quite some time now, for a few lessons. Now we'd like to be able to solve equations with them. So to be able to do this, there's really only a few skills we need to, or a few new things we need to understand. Remember when we're solving, we like to use opposites to kind of undo operations that are showing, and we're wanting to undo operations like square root or operations like cube root. So the question is, what's the opposite of that? What's the opposite of a square root? I've mentioned it in some of the other lessons. The opposite of a square root would be squaring something, right? And what's the opposite of a cube root? Well, the opposite of a cube root is a third power or a cube. So for instance, if I have the square root of x, or let's go two very simple equations to help us kind of see what I mean. So if I have the square root of x is equal to 3, or I have the cube root of x is equal to 2, I can solve each of these because I know the opposite of a square root is a square that undoes it. Now, whatever I do to one side, I have to do to the other. And so, square and square root cancel. I'm left with x equals 3 squared is 9. You could plug that in and check, put the 9 in there. Square root of 9 is 3. Okay, that worked. Over here, I have a cube root. The opposite of a cube root is a third power. Whatever I do to one side, I have to do to the other side. Third power it. The third and the cube root cancel. I'm left with x equals 2 to the third. 2 to the third is 8. Okay, and you could plug that in and check. The third cube root of 8 is 2. Okay, so to undo square roots, we're going to square things. To undo cube roots, we're going to cube things. There's maybe only one or two other important things you need to know. If I have a lot in, well, if I have stuff on the outside, like plus 3 equals 5, I have to get rid of that first. So I have this right here, so I need to subtract the 3 over first before I can consider squaring or cubing or whatever both sides. So you need to get the radical by itself first. So that's kind of one note, is before you use this opposite idea, you need to get radical by itself. Okay. And then the other really important thing after you square or cube root both sides and solve it is because we're doing something kind of interesting by squaring both sides, sometimes we introduce extra solutions which are not correct. So one thing that I would strongly suggest throughout this chapter is always check these. Always check these solutions. Okay? Because there are chances for us to get what's called erroneous solutions, which are extra ones that we introduced by squaring both sides. Okay, so let's actually just jump into some examples from here. I think that's like all the information you need. I think we should be able to solve these. Let's just dive into some examples. So for our first simple example, we'll go with 2x minus 3 equals 3. And so the very first idea is the radical expression all by itself on its side of the equal sign. The answer is yes. There's no operations outside of it. And so to undo it, we are going to square this whole side to undo the square root, which means I need to square the entire other side. Okay. Well, we get lucky or happy that the square and the square root cancel, so I'm just left with 2x minus 3. Bring down my equal sign, and when I square this side, 3 squared is 9. Nice, okay. Now this is just a simple solve. I need to add 3 to both sides. So 2x equals 12, and then I need to divide by 2. So x will equal 6. So we should check our solution, but I feel pretty good. We might could check it in our heads. If I put 6 in there, 2 times 6 is 12. 12 minus 3 is 9, and the square root of 9 is 3. So yes, we did very, very well. Okay. So that's not too hard. Let's do a few others of these. We'll do one right beside here. A few others. We'll do a few more square roots, and then we'll dive into a cube root, one or two. And then I'll give you an interesting one. Okay. So let's try the square root of 3x minus 2 equals 5. So once again, we have to start with, are there any operations outside of the radical? No, so I can jump in to cancel it out. This is a square root, so squaring it will cancel it out. But because I'm squaring the left side, I'll have to square the right side as well. Okay, and so the square root and the square cancel, and I'm left with 3x minus 2 is equal to 5 squared, which is 25. Okay, now I have a simple solve. Add 2 to both sides, add 2, so 3x is equal to 27, and then I need to divide both sides by 3, and so x will be equal to 27 divided by 3 is 9. Woohoo! I should check it. So let's take 9. 9 times 3 is 27. 27 minus 2 is 25. Square root of 25 is 5. All right, yes. Feeling good. Okay. Now, let's do one more square root one before we dive into some cube roots. So let's see. One like this. Square root of 3x plus 4. Outside of this thing, we have plus 3. Let me make this a little shorter so it's obvious. Plus 3 equals 8. And we say, aha, we have our first one where something is outside the radical. Well, how are we going to handle that? Well, not with really much stress. We're going to say, okay, well, we know how to cancel out this plus 3 by subtracting 3 from both sides. Now we have simply given ourselves an equivalent equation. 8 minus 3 is 5. That is not too hard to solve. We now have a square root with nothing outside of it, so we are going to cancel that out with a square. Because I'm squaring the left side, I have to square the right side. Of course, the square and the square root cancel, and I have 3x plus 4 equals 5 squared, which is 25. And then we could keep working from here. I could subtract the 4 from both sides. So 3x equals 21. Divide by 3 on each side, and x equals 7. You should check this, but that's going to be fine. That works. Okay. All right. That's really not that hard. Hopefully you're not intimidated by that. Hopefully you enjoy that. That's kind of enjoyable. Let's try a cube root one, which will be really no different. So a cube root of x plus 1, let's say it equals 2. So same idea. Is there any operations outside? No. So I can jump into, to get rid of a cube root, I will raise to the third power. Because I did it on the left side, I need to do the same thing on the right. So the cube and the cube root cancel, and I have x plus 1 equals 2 to the third power is 8. All right, well, I just subtract 1 from each side, and x will equal 7. Okay, and you can plug that in and check, but it'll work out fine. Okay, one more cube root, and then I'll give you a special one. One more cube root, just to practice the cube root ones. Let's go with, let's see, x minus 5. Outside of here, I'll go plus 2 equals 1. Okay, well, you know that I'm not ready to get rid of this cube root because I have an operation outside of the radical on this side. But that's okay. How do I get rid of a plus 2? I subtract 2 from both sides. Ooh, this is interesting. And so what I'm going to get is a cube root of x minus 5 equals a negative 1. Now, I have a good question for you. If this was a square root equals a negative number, could we do anything with that? Maybe, maybe not. That would be one where I definitely would encourage you to check your answer and see what happens. Just a food for thought. Just think about it for a second, okay? But this one, cube roots are not going to bother me. So I'm gonna raise both sides to the third power. So I can cancel the cube root out, and I'll have x minus 5 is equal to, now negative 1 to the third power is negative 1, because if you don't believe me, that would be negative 1 times negative 1 times negative 1. Just 3 of them, right? Negative 1 times negative 1 is positive 1. But then I got to multiply by negative 1, and that would be negative 1. Okay. Alright, now, this is a very simple solve from here. I just need to add 5 over. And x will equal negative 1 plus 5 is 4. Alright. Okay, and you could check that one. That one will work out. Okay, that's not too hard. Let's go on to maybe a little more challenging, which is still not any harder. But our last type that we'll do, okay? Let's just say this will be our last example. Maybe I'll do 2 of these, but 1 minus x square rooted is equal to x plus 5. Now this is not looking too bad. I know that there's nothing outside the square root, so we'll just handle it the same way and square that. Now because I squared the left side, I'll need to square the right side. Now notice I put it in parentheses. I've been doing that because we're squaring the entire left side. I have to square the entire right side. This becomes interesting then, because the square and square root will cancel, and I'll have 1 minus x. But this side will square this. Now, if you remember the pattern, that'll be x squared plus 10x plus 25. If you don't remember the pattern, take the time to FOIL it out. I don't care if you remember it or not, and you will get the same thing when you've done that. Okay? Now, to solve with an x squared, I'm probably going to want to subtract everything over onto the same side. So let's see, add x. So I'll have 1 equals x squared plus 11x plus 25. And then I need to subtract 1. So I have 0 equals x squared plus 11x plus 24. And so now what I hope for is I hope for this to factor, because at this point in the course, we have no other way to solve this. Let's see, they look like they're both going to be positives. All right, so is there anything that multiply to 24 that adds to 11? And hopefully you've said, yeah, that's 3 and 8. All right, so now what I'm going to do is I will set each of these equal to 0. And I can get 2 solutions. Minus 3 from both sides, so x is equal to negative 3. Minus 8 from both sides, so x is equal to negative 8. So there are 2 solutions. Now, let's carefully check to see if both of them are true. Maybe I'll actually show myself checking it this time. So negative 3 and negative 8 are our solutions. So let me put a little box here for this work. So square root of 1 minus blank, I'll put it in parentheses, equals blank plus 5. So let's check the first one, negative 3. Okay, 1 minus negative 3. Let's see, minus and negative is like plus. So that becomes 1 plus 3, which is just 4. Let's see, a negative 3 plus 5 is just 2. And the square root of 4 is 2. Okay, so that one checks out. No stresses with that one. Let's check the other one here and see if it checks out. Like I said, if I'm going too fast on any of this, just pause and think. All right. So if I put a negative 8 in both of these. All right, well, minus a negative makes a adding, so that's 1 plus 8. That's 9. All right. Negative 8 plus 5 is negative 3. Square root of that's 3. 3 equals negative 3. That's not right. This is an erroneous solution that we've introduced, which is not one of our solutions. Okay? So that's why we always check these, because you could have one that ends up not being true. All right? Now, I think I'll end it there. Try the homework. If you do have any questions, please email me. But good luck with that, and I'll see you next time.